Hello everyone, so we start with chapter 1, Electrostatic. We have two types of electrostatic forces, the repulsive force and the attractive force. Charges will experience the repulsive force if they are the same type of charge. Like in this case, Q1 and Q2 both are positive, so they will feel the push force caused by each other's charge. While for attractive forces, the charges will feel attracted if they are the opposite types. So what causes the forces to become big or small? The first case, we have two charges. Obviously, they repel each other. The length of the arrow represents the magnitude of the force, okay? If it is long, then the force is big. If the arrow is short, then the force is small. The bottom case, charge Qx and Qy are smaller than Qm and Qn. The electrostatic force is much smaller for Qx and Qy. Hence, we can conclude that the bigger the charges, the bigger the force. So F is directly proportional to Q's. The next case, we're going to use the same size of charges, but this time we're going to put them in different distance apart. The charges at the top are much more farther away than that of at the bottom. But look at the lengths of the arrows. The ones that have smaller radius have bigger forces acting on each other. So force is inversely proportional to the radius. But because the relationship is non-linear, then R is squared. So from here, that's why we got F equals to K Q1 Q2 over R squared. This is the Coulomb's law equation. Next, how do we write the label of the forces? Remember this, force is impossible to be produced if you only have one body or one charge in this case. So for simple case like this, we have Q1 and Q2. We're going to use the on-by principle. Force felt by Q1 is F on charge 1 caused by charge 2, F12. And force felt by Q2 is F on 2 by 1. Since F equals to Q1 Q2 over R squared means that the F12 is equals to negative F21 because they are opposite to each other. Alright, that's all.